Hey everyone, welcome to Astar Math. In this video, we're going to go through chapters 1 and 2 of Edexcel IAL Pure Mathematics 1, P1. I'll explain the key concepts, break down the theory, and walk you through some worked examples straight from the textbook. I've linked the textbook in the description below, so make sure to download it and follow along. Okay, let's get into it. So we'll be going through chapter 1, which is Algebraic Expressions, and chapter 2, which is about quadratics. So starting off with the key index laws you need to know. So the first one is a to the power of m times a to the power of n equals to a to the power of m plus n. Then we have a to the power of m divided by a to the power of n equals to a to the power of m minus n. Then we have a to the power of m whole to the power of n equals to a to the power of m times n. You can also write it in this way for ease of understanding. And then we have ab to the power of n, which is also can be written as a times b whole to the power of n. This is equal to a to the power of n times b to the power of n. Then we have anything to the power of 0 is equal to 1, so a to the power 0 equal to 1. Then we have a to the power of negative m. This is equal to 1 over a to the power of m. Then we have a to the power m divided by b to the power m, so the same power. This is equal to a divided by b whole to the power of m. Then we have a to the power m divided by n. This is equal to the nth root of a whole to the power of m, or you could write it as a to the power m, the nth root. So basically the nth root of a to the power m. Then we have a to the power 1 over m. This is equal to the mth root of a. And we have now moving on to surds. So root of a times b is equal to root a times root b. And then similarly, we have root of a over b. This is equal to root a divided by root b, or you can write it as root a over root b. It's the same thing. Okay, so now we move on to some examples. I've used the examples from the textbook. So let's start. Number 1, x to the power 2 times x to the power 5 is equal to x to the power 2 plus 5, which is x to the power 7. And then the next one, if we have 2r to the power 2 times 3r cubed, this will give us 2 times 3. You first multiply 2 and 3, so that gives you 6, and then you do r squared times r cubed, which is r to the power 2 plus 3, and you combine it, so that's 6r to the power 5. And then we have b to the power 7 divided by b to the power 4. It's simply b to the power 7 minus 4, which is equal to b cubed. Then we have a cubed whole squared times 2a squared. So you first simplify the first bit. So a cubed whole squared is basically a to the power 3 times 2, which is a to the power 6. You multiply it with 2a squared, so that will give you 2a to the power 6 plus 2, which is 2a to the power 8. Okay, so now how do you remove a root from the denominator? So let's say we have 1 divided by root a. So basically you do 1 over root a times root a over root a. So this will basically remove the root a, like the root, from the denominator. Perfect, so now let's move on to rationalization. This is very important for your exam. So we have 1 over a plus root b. So how do you rationalize it? So you're going to do 1 over a plus root b times a minus root b divided by a minus root b. So basically the a minus root b over a minus root b is practically 1, but when you multiply it, it will remove the root, like the a minus root b, and to make it like, oh, a singular integer number in the denominator. So as you can see, let's simplify it. A minus root b divided by a plus root b into a minus root b. So now we're going to learn this later on in the video, but a plus root b times a minus root b is the difference of two squares. So when you multiply it, it's basically a squared minus root b whole squared. So that's a squared minus b in the denominator. So as you can see, we have removed the root from the denominator again. So a squared minus b, and when you're working with like figures in the exam, it will come to become an integer. So now let's say we have 1 over a minus root b. How do you rationalize that? So it's 1 over a minus root b times a plus root b over a plus root b. So these two things are the key things you need to know for rationalization. Basically, this sign in the middle of the denominator is what you flip when you're multiplying. So let's say, like, you have 1 over a plus root b. But when you're multiplying it, you change the plus to a minus, and you just multiply it both in the denominator and the numerator. So it's that simple. And then what you need to know is basically how to how to expand and simplify it, and you'll be able to easily rationalize the denominator. Okay, so now let's look at some examples again. So I'll start off with the removing the denominator. So if you have 1 over root 3, how do you remove the root 3 from the denominator? So basically, you use this formula, the first one. So 1 over root a equals to 1 over root a times root a over root a. So you can see we've done the same thing. 1 over root 3 times root 3 divided by root 3. So this gives me 1 times root 3 in the numerator and root 3 times root 3 in the denominator, which gives me root 3 over 3. Okay, next up. Now rationalizing the denominator. So we have 1 over 3 plus root 2. So remember the sign. Always use the opposite sign when you're multiplying. So we're using the first rationalization formula. So that's 1 over 3 plus root 2 multiplied by 3 minus root 2 divided by 3 minus root 2. So that gives you, in the numerator, it'll just give you 3 minus root 2, as 1 times 3 minus root 2 is 3 minus root 2. And in the denominator, as you can see, it's again difference of two squares. So 3 plus root 2 times 3 minus root 2. So you square 3, that gives me 9. And you square root 2, which gives me 2. So that's 9 minus 2. So it's going to be 3 minus root 2 divided by 9 minus 2, which is 3 minus root 2 divided by 7. As you can see, it's come to an integer in the denominator, and you have rationalized the denominator. Okay, so now let's move on. So ax squared plus bx plus c is going to be a quadratic equation. That's basically the format of a quadratic equation. Okay, so now we move on to the most important bit. These formulas will sort of help you so much when expanding. So how do you expand a plus b whole squared? Sorry guys, the x is not supposed to be there. So ignore the x. So a plus b whole squared is basically a squared plus 2ab plus b squared. And then the second one is a minus b whole squared. Sorry guys, again, ignore the x. So it's a minus b whole squared. This is equal to a squared minus 2ab plus b squared. So the difference we see is only in the signs of the middle bit, the 2ab. So now the difference of two squares, which I was talking about. So a squared minus b squared, if you factorize it, you get a minus b into a plus b. Right, so a minus b into a plus b equal to a squared minus b squared. Remember that it will help you so much when expanding, factorizing, trying to cancel things out. It will help you so much. It's very important. Moving on to some examples for the things we've done. So the first example is So how do you expand x minus 4 into x plus 3 into x plus 1? So what you're going to do is first you expand the first two brackets, right? So x minus 4 into x plus 3. So let's write that in a big square bracket. So that's our starting point, okay? Okay, so now what you want to do is you multiply x by x and x by 3. So basically it's going to be x into x plus 3 minus 4 into x plus 3, right? So x times x is x squared, x times 3 is 3x, negative 4 times x is negative 4x, and negative 4 times 3 is negative 12. Now you multiply that by x plus 1. So first simplify the first bit, which is x squared minus x minus 12 into x plus 1. Now we can do the same thing, same process. So x squared into x plus 1 minus x into x plus 1 minus 12 into x plus 1. So x squared into x is x cubed, then plus x squared minus x squared minus x minus 12x and minus 12. Now simplify, so x squared and x squared cancels out, so we have x cubed minus 13x minus 12. And it's so simple, like it's very simple. Just do it step by step and make sure not to make any errors in the process and you get it easily. Okay, now moving on to the second most important thing, factorizing. So how do you factorize x squared minus 5x minus 6? So you need to find two numbers whose product is equal to negative 6. So when multiplied, you get negative 6, and whose sum is negative 5. So when you add them, you get negative 5. Okay, so the two numbers are going to be negative 6 and 1. So negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So a simple way of actually finding these numbers is by using the quadratic function on your calculator. So if your coefficient of x squared is 1, like ours is, so there's no number before x squared, you simply put in the equation on your calculator and let it give you the answers in terms of x. So like it'll give you x equal to 6 and x equal to negative 1, right? So since x equal to negative 1, you just flip the sign and write x plus 1. And since x equal to 6, you flip the sign and write x minus 6. But if you can also do it offhand, then well and good. And you can easily get your answer. So your numbers are 1 and negative 6. Don't change the signs. Leave it as is, x plus 1 and x minus 6, right? So we've done index laws, expanding brackets, factorizing, negative and fractional indices, surds, rationalizing, denominators. So we've done chapter 1. So let me just take you back, and okay, so this bit which I'm highlighting is surds. Just in case you thought we missed the topic, that is surds. Okay, so moving on to chapter number 2, quadratics. Okay, so as I told you before, ax squared plus bx plus c is a form of the quadratic equation. So how do you solve a quadratic equation? So let's start with 2x squared plus x minus 3 equal to 0. So we have three methods of actually solving a quadratic equation. Okay, so the first method is factorizing. This is what we had learned in chapter 1. So now this is a bit different, right? Because there's a coefficient of 2 in front of x squared. So the product is supposed to be equal to 2 times negative 3. And the sum is equal to 1. Okay, so now think about what two numbers can fit this criteria. So negative 3 and 2. So negative 3 times 2 is negative 6, and negative 2 plus 3 is equal to 1. So write 2x squared plus x minus 3 equal to 0. So now we're going to replace x with negative 2x plus 3x. This is because negative 2 and 3 are over two numbers. And from this, between the first two, you can see 2x is common, so take it out. 2x into x minus 1. And 3 is common in the next two, so 3 into x minus 1. So now x minus 1 is common, so take x minus 1 common out. You get 2x plus 3 into x minus 1 equal to 0. Now equate each bit in the bracket equal to 0. You get x equal to negative 3 over 2 and x equal to 1. And you've solved your quadratic equation. Now moving on to method number 2, the quadratic formula, my personal favorite. You can literally never go wrong with this. So simply, x equal to negative b plus or minus root of b squared minus 4ac divided by 2a. This is your formula. So remember, our quadratic equation was of the form ax squared plus bx plus c. So in this case, my a is 2, my b is 1, and my c is negative 3. Be sure to be careful of the sign. And what you do is simply input it into the equation. And you get your answers, x equal to negative 3 over 2 and x equal to 1. Okay, so now what we're going to do is move on to method number 3. This is completing the square. Now this method is, I would not recommend you to use it for solving unless you're very comfortable with it. This method is mainly used to sketch a quadratic curve. So how do you complete the square? So if you have an equation x squared plus bx, it's basically, the formula is basically x plus b over 2 whole squared minus b over 2 squared. Make sure to not take the minus into the squared because that would give you a positive and it would mess up your answer. So remember this, it's very important for sketching like I said. And we'll learn later on in this video why. So 2x squared plus x minus 3 equal to 0. The first step is to take 2 common out. So that will be 2 into x squared plus half x minus 3 over 2 equal to 0. And the bit you can actually complete the square is x squared plus half x. So that gives me 2 into x plus 1 over 4 whole squared. The half is your b. Minus 1 over 4 squared minus 3 over 2. Again, ensure not to take the negative into the square. So that, open it out, 2 into x plus 1 over 4 squared. Let me calculate that really quickly. Okay, so that gives me negative 25 over 8 equal to 0, right? So how do you solve this? You make x the subject. So x plus 1 over 4 whole squared. You take the 25 over 8 on the other side, divide by 2. That gives me 25 over 16. So now root. So x plus 1 over 4 is equal to plus or minus root 25 over 16. So now we make x the subject, x equal to plus or minus 25 over 16 under the root minus 1 over 4. So that will give me two answers since there is one with the plus and one with the minus. So x equal to 1 and negative 3 over 2. And if you see, all three methods give me the same answers, x equal to 1 and x equal to negative 3 over 2. So let's move on to functions. It's very simple. So remember, when they ask you about range, you're talking about the y values. And when they ask you about the domain, you're talking about the x values. Alright, so now on to the most important bit. How do I sketch a quadratic function of ax squared plus bx plus c equal to 0? So now, these are very basic rules. So if the coefficient of x squared, which is a, is greater than 0, then you have a U-shaped curve with a minimum point. The turning point is a minimum. So that dot I've drawn is where the minimum point is. And if your coefficient is less than 0, so if a is less than 0, then it is an N-shaped curve with a maximum turning point. So the minima and the maxima, or rather the dots, is where your stationary / turning points are. This is where your gradient is equal to 0, so you equate dy by dx equal to 0. Okay, so the first step is to complete the square. This is where you realize that completing the square is very important for sketching a curve. So this is an example. If after you complete the square, you'll get a form of a into x minus h whole squared plus k. Now step number 2 is to find the turning point. Now you find the turning point using your completing the square. So equate x minus h equal to 0. That will give you x equal to h. And when you put x equal to 0, you get y equal to k. So your turning point will be hk. So basically, for the x value, you change the sign of h and of this negative h, and for the y value, you just take k. You don't change any sign. Step number 3, you make x equal to 0 and find the y values. And lastly, step number 4, you make you make y equal to 0 and you find the x values. So this, you will also need to know how to solve a quadratic equation, because when you make y equal to 0, you get a quadratic equation equal to 0 and you will find two x values most likely. Step number 5, plot all your points on the graph. So as you can see, I've plotted a graph of a quadratic equation. So this is just an approximate, like you can have a minimum point, a maximum point. It all depends on your points and what you find. So basically, you can see where the curve crosses the x-axis, you will find from step 4. Where it crosses the y-axis, you will find it from step 3. And you will find the turning point from step number 2. The quadratic curves are always symmetrical. So your turning point is going to be halfway between the points where the two values cut the x-axis. Alright, moving on to roots of a quadratic equation. This is very important to know if in the exam they ask you to find the coefficients of x squared, x, and the term independent of x. So the discriminant is equal to b squared minus 4ac. Okay, so this table shows you everything you will need to know for roots of a quadratic equation. Okay, so let me remind you of the quadratic formula. X equal to negative b plus or minus root of b squared minus 4ac divided by 2a. Sorry, the 2a has cut off. So b squared minus 4ac is the discriminant. So let me just number these, 1, 2, and 3. So, okay, in number 1, the b squared minus 4ac is greater than 0. It has two real distinct roots. That means when you equate it to 0, the quadratic, and you solve it, you get two like real numbers. This is because b squared minus 4ac is positive, so you shall have a positive b squared minus 4ac under the root and a negative one. So you'll have two answers. And when b squared minus 4ac is equal to 0, that's for situation number 2, you will have two real equal roots. What this means is you get two answers of x, but they will just be the same. So Since b squared minus 4ac is 0, you will no longer have a plus and a minus. So your x value, answer, will just be equal to negative b divided by 2a. And for number 3, you cannot take a root of a negative number. So if b squared minus 4ac is negative, it's not possible. That's why you will have 0 real roots. For those of you taking the further pure units, in F1, you will come to learn that you can have answers which are imaginary. So we've come to the end of chapter 2. Remember, for solving quadratic equations, we have 3 methods. And for functions, it's simply, all you need to know is just the domain and the range. This was just an overview. We will be working on past papers. This is when you get the real understanding of these topics and basically the whole of B1. That's it for chapters 1 and 2. I hope this helped make things clearer for you. If you found it useful, don't forget to like, subscribe, and drop any questions in the comments down below. The next video will cover chapters 3 and 4. So make sure to stay tuned and follow along as we keep building your formula booklet together and get yourself an A star and 100% in P1. Thanks for watching and see you in the next one.